Hey guys, this is the last kind of five here. So we are last technique. We call this elimination, and the whole point of this is to eliminate a variable to make it easier to solve. So first part right here, we have this list of expressions on the board. How can you make a list of fewer expressions that has the same combined value of those shown on the board? Write the expressions and explain your reasoning. So you've got variables here. We've got numbers, right? We have two different variables. We have x and y. So the idea here, oh, and we have just regular numbers as well. The idea is you kind of want to combine your variables together. So I like to just, I've got my x's right here. So I'm going to say 3x. And then I'm just going to say minus 2x, negative 5x, plus 5x. And then I'll do my next one. What's it? 1, 2, 3, 4. Yep. And then I have y, so plus 2y minus 3y. That's that. And then for the constants, which is just the regular numbers, I say plus 5 minus 3. And so I'll just kind of combine them together here. 3 minus 2 is 1 minus 5. Actually, let's boom. Those get eliminated right away, so we don't have to worry about it. And then 3 minus 2 is 1, so just x. And then 2y minus 3y, negative 1, right? And then 5 minus 3 is 2. So you can, it's basically the same value, but because of all the negatives, they kind of come down, right? So we can actually simplify this even a bit more, x minus y plus 2. So yeah, that's the reasoning there is you just combine the variables together, combine like terms, and put them over there. Yeah. Okay, so we have this system of equations here. They're both in standard form, so we could, subtract that 2x over here and then substitute it in. But there's actually a better way to do it when they're set up like this, when they're both in standard form. And this is you just combine or add. Combine, because sometimes you'll do subtraction, but you'll add these together. And the point here is that you want to get rid of the variables that match up, right? So you have this 2x and that 4x, those don't match up, but this y and this 1y, right? Because they're technically, there's both a 1, there's a 1 in front of each one as the coefficient, right? So if you add them together, right, 2x plus 4x is 6x, okay? 1y minus 1y is 0, and 8 plus 4 is 12. So we went from these two fairly complicated equations to something that is so simple to solve, right? Oh, shoot, what are we doing? Should have done it down here just to follow the steps, right? It's the same thing. I'm just going to rewrite it. Equals 4. Okay, so we add them together. We end up getting 6x equals 12. We divide by 6, and we get an x value of 2. All right, so now we're halfway done. We're going to take this 2 and plug it in for the x. I'm going to do it in this first one because we don't have to deal with that negative, okay? So it becomes 2, right? This 2 is that 2 right there. And then that x is going to become this 2 because x equals 2, right? And then we add y equals 8. Okay, and then we're going to combine those together to get to 4 plus y equals 8. And then we subtract 4 to cancel, and we end up with y equals 4. So our equation, our two systems of equations, right, come out to a, sorry about that, a solution of 2, 4, right? So let me do that over because it was off camera here, right? So this 2 right here is that 2, okay? And then this 2 is that 2. So you multiply those together to get 4 plus y equals 8, and you subtract that 4 to bring it over there to get to 4. So that's it right there, guys. Very easy. Honestly, in some circumstances, this is as easy as graphing. Yeah. Okay. It's the same thing right here. 2r plus 3s equals 14, and 6r minus 3s equals 6. Now, these are different variables, these are different coefficients, so we're not going to try to eliminate those. These are the same coefficients, so that's what we want to eliminate. So we add them together. Right? 2r plus 6r gets, it's down here. Come on, Dave. 2r plus 6r gets you to 8r plus 0 equals 20, right? 14 plus 6 is 20. So 8r plus 0 equals 20. Was that right? 8r plus 0. Yeah, that's right. Then we'll divide by 8. Actually, hold on here. Sorry, guys. Okay, so we've got that 8r plus 0 equals 20, which we can simplify to just be 8r equals 20, right? You divide by 8. Okay, it's going to give us a fraction. That's okay, or decimal. That's why you have calculators, right? 20 divided by 8 gets us to 2.5. Okay, so now we're going to take this 2.5 and we're going to sub it into the r, which is right here. Okay, 2 times 2.5 is 5s plus 3s equals 14. Oh, my bad. 5 plus 3s because the r is gone, right? And then we'll subtract 5 to get to 9, and then we divide by 3 to get to 3. So that's your solution right there, 2.5 comma 3. Okay, so that was how you solve by adding, right? And what you're looking for here again is that same coefficient, right? So that 1 and that 1, and we don't eliminate those because they're different, okay? So you look for the same coefficient and then you add them if they're different signs, okay? So if they're different signs, if one's positive, one's negative, then you add them. But if you set them up like this, then we're going to be subtracting. You'll see what this looks like in a second, okay? So Hannah is helping her younger brother learn to count money. She gave a total of 20 coins, nickels, and pennies, counted 68 cents. How can Hannah solve a system of equations to tell whether he counted the money correctly? So we'll say x equals number of pennies, y is a number of nickels. Okay, so we know that there are 20 coins. So first equation we're going to set up is x plus y equals 20. So that's just the number of coins, okay? And then the other number in there is at 68 cents, right? So this is basically the value of how many coins you have. Now, pennies are each worth 1. So the coefficient for those is just going to be 1. But nickels are worth 5.5, actually, 0.05. Y. Just like that, okay? And then we set it equal to 68. All right, so now we're going to eliminate one system by subtraction, okay? Now, how you know you're going to subtract is you're looking for that same coefficient again. It's the x's because there's each a 1, right, in front of those x's, so that's what you're going to eliminate. You look for that matching coefficient. But since it's, that's why this is looking weird to me. Okay, all right. Technically, this is 0.01, right? So we're going to talk cents right here. So this is actually going to change this, right? So this is 1 cent. This is actually going to be 5, where we move the decimal, and this will be 68. Hope that's right. Anyway, so we'll eliminate one variable by subtracting. So we've got x plus y is 20. Okay, and then we've got x plus 5y equals 68 cents. Okay, so now we'll subtract. And that's what's a little different is you're going to have to put these parentheses in here to kind of like make sure you're applying it right. X minus x is 0, so we don't even need to write that. Y minus 5y is negative 4y. Okay, and then 20 minus 68 is negative 48. Yeah. So then we'll divide by negative 4. Sorry if I'm running out of room here. And the good thing here is that those get eliminated, right? The negative divided by a negative, so 48 divided by 4 gets you to 12. So solve for the other variable. So now we actually have a y equals 12, which we actually, I don't know if we've seen that much, but we're going to take this y and plug it in for that equation right there. So it's going to become x plus 12 equals 20. Okay, now we'll subtract 12. And we get to x equals 8. Okay, so we have 8 pennies, right? X's are the pennies. Yeah, 8 pennies and 12 nickels. Right, which makes sense, right? 12 times 5 gets you to 60 cents. plus 8 gets you to 68 cents, which is exactly what we want. Okay. Solve a system of equations by multiplying. The difference of the length and width of the rectangle is 3 centimeters. What are the length and width of the rectangle? Oh, shoot, hold on, guys, sorry. Okay, so we've got our length and our width, so we've already got our variables defined, right? L equals length, W equals width. So we have the perimeter is 26. So the difference of the length and width of the rectangle is 3 centimeters. So we can basically say length minus width equals 3. That's our first equation. And then our second one, we have it set up as our perimeter. So we know it's going to be perimeter of 26. And the idea here is perimeter is all the way around, right? So it's a length, a width, and a width. So it's 2L, because there's two lengths, plus 2W equals 26. Okay? And this is where this type of one gets a little tricky, because what we can see here is we don't have any matching coefficients here, right? So we don't really have anything we can multiply by. Okay. All right. Sorry, we don't really have anything that we can't just add or subtract it. So what we do is we figure out a number to multiply to get rid of one of these variables, right? And so what we can do is we can actually match, right? Because these technically 1. 1 times 2 is 2. So we're going to multiply one equation by 2, right? So it's going to be, if we multiply this whole thing, right, it's going to be 2L minus 2W equals 6. Okay? The trick is when you're multiplying by 2, you have to multiply it by everything inside. So this first variable, the second variable, and the answer to it, okay? And so now we've got our plus 2W right here equals 26. And so what we can do, we can eliminate these just by adding them together, right? So 2L plus 2L is 4L. Those get eliminated, and that gets us to 6 plus 26 is 32. We divide by 4, and we get a length of 8. Okay, so we know our length is 8. We can plug it into one of these equations. This is probably the easier one. So we can just say 8 minus W equals 3. That's fine. Okay, so we get to negative W equals negative 5. And then we can divide by the negative 1 that's out front there, that invisible one. And we get to a positive 5 for the width. Okay, so our length is 8 centimeters. Our width is 5 centimeters, so it's 8, 5. Cool. All right, this is going to go in your notebook, folks. So we're going to build this half hamburger style. I think I actually want to leave a space in here because I wanted to put the reference page in there. Okay, so this is going to be on page 7. Okay, just like that. Okay, so I'll skip one because I'm going to put that reference page in there. So that's 5.4. This was solving systems of equations by elimination. The final method for solving systems of equations. Right.